Hey kiddos, I know the last video from converting from base 10 to base 2. I want to talk about how you could use that same method to convert from base 10 to octal or vice versa. Okay, so give you an example. 31. If I want to turn base 10, 31 into octal, I would do the same method that I did with base 10 being converted into binary. All right, so 8 will go into 31 how many times? 4 times 8 is 32, so 3 times 8 is 24, right? So 8 will go in 3 times, and that'd be 24. 24 from 31 is 7, correct? Just, so will 8 go into 3? No, we're done. That's it. We're done. So we take what's the remainders. These are the remainders. Okay, the remainders. So because 3 times 8 is 24. 24 from 31 is 7. That's the remainder. And then will 8 go into 3? No. So that's what's left over too. So the answer is 37. So if you look on the chart, 31 base 10 is equal to 37 base 8. Let's do another one. Let's do 16. 16 is a little special. If we do any other bases higher than base 10, it's a little special. So let's do base 16. Remember, the remainders is what we're looking for, right? So 16. Okay. How many times was 16 going in? If you do 2 times, that's 32. So we can't go 2 times, so we can only go 1, right? So 16 from 31 is what? 15. So the remainder is what? 15, right? And how many times did it go in there? How many times did it go in there? 1 time. We're done. Can 16 go into 1? Now we're done. So here's our answer. We can't write it like this, can we? Right? Because that's weird, isn't it? Remember, we're past the base 10, so we got to convert that into letters, don't we? So, remember, how's it go? 9, right? We got 9 fingers. We're at 9, okay? Now we got it, because we're past, we got to finish out the single digits, right? So 9, A, B, C, D, E, F. That's 15, so it's F. So basically 15 is actually F. So 1F, 16, base 16 is the same as 31 base 10. Hopefully you understood that. I think we did this last year a little bit. I went over it a little bit using your fingers to kind of help you. Because you remember, hexadecimal after 9 is letters. Any other number system like 13, if we use 13 in here, right? If we did 13, let's do 13. Let's just do 13 for fun. All right, let's do 13. How many times would 13 go in here? 2 times, that'd be 26. But I don't think we'll go anymore, right? So we know it'll go in there. So 31 and 26. 6 from 11 is 5, right? And then 2, that leaves 5, right? Correct? So that leaves 5. So the answer is 31 base 10 is the same as 25 base 13. I was trying to give you an example of the lettering, but in this case we didn't have to worry about it. So, but hopefully you'll understand what I was talking about on that again. I'll go over it one more time because I want you to make sure you understand what I did when we did that problem with hexadecimal. So 16, right? Dividing 16 into 31. 16 will go into 31 how many times? We know if we do 2, that'll be 32, so it's too many. So we know it goes into how many times, right? 16 will go into it 1 time. So what's the remainder after you do that? The remainder is 31 And 16, 6 from 11 is 5. And 1 from 2 is 1. That's 15. But that'd be incorrect. That would not be 115 hexadecimal because we don't have that, right? Well, we do have it, but it's that. But we're not talking about base 10. So we have to convert that to the letter. Remember? So start with 9 fingers because we're already at 9 fingers, right? After that is when it turns to letters. So 9 fingers, and then we go A. So that's 10. A, B, C, D, E, F. That's 15. So F is 15 in hexadecimal. So we just converted it to F. So now the answer is actually 1F. So 1F base 16 is the same as 31 base 10. I hope you really understood that, because when we get in the bases that are bigger than base 10, we need to understand how to, we might have to use our fingers, or maybe remember this, A, B, C, D, E, F, G, H, I, J, K, or something like that to help us quickly get to the answer, all right? Hopefully that part of it was informal. Let's do another one. Let's do 44. Hopefully you're kind of pausing this and practicing yourself to see what you get. I'm going to do base 8, all right? Base 8, right? How many times will 8 go into 44? We know 5 times 8 is 40. So if we add another 8 to that 40, it'd be 48. So that'd be too much, right? So we'll know that 8 will go in there 5 times, right? So that's 40. So what's the remainder? 4. Will 8 go into 5? No. So we're done. Here's our answer. So 44 base 10 is the same as 54 base 8. We take this number and this, we go upward. Okay? And that's our answer. 44. If you look on that chart that I gave you, base 10, 44 is the same as 54 base 8. Okay? Let's do 16. Let's do the same thing with hexadecimal. I want to use that because it has letters in it. So just in case it comes up with that, we can look at that, right? So 16. How many times will 16 go in there? We know it'll go 2 times because that's 36. But any more than that, that would be 48, right? So we know the 16 will go in it 2 times, correct? So 16 with 32 from 44. So 2 from 4 is 2, right? Right? And then 3 from 14 is 1. Hey, wait, look. We've got that same problem, right? It's not a single digit. It's not 0 through 9, is it? So we got to convert that, remember? So again, start with 9. And then A, which is 10. B, C, which is 12. So it's C. So 12 is C. So base 10 is the same as 2, good Lord, C base 16. And I do not know what happened there. Do you see what happens when you get old? You make your C's backwards. What? Am I becoming? Well, we're not going to go there. All right? I don't even know if that's the right C. Who knows? I'm losing my mind. But hopefully that was a good explanation, just like the other method that I showed you is the same method, okay? And sometimes it gets longer just to be depending on how big that is, okay? Hopefully, if you have any questions, email me.